Hello, Legacy Sabers. Marsh here. So today we're going to be looking at solving logarithmic equations. You're going to want the foldable. You may need the perfect roots chart, but main thing you're definitely going to want is a calculator today. So first thing we're going to do, let's refresh our brains on how we have solved an equation similar to this. Last time we met, we talked about how to solve an exponential equation similar to this. We were saying, well, we had the same base, right? We could make a common base. So over here, I could make this 2 to the third, right? Because 2 to the third is 8. Because we used our little perfect rush chart and we said, where is there a 2 and an 8 on the same row? That was the 2, the rows of 2, right? So we rewrote our problem, and then we said, well, let's just, now we have the same base, let's just set the exponents equal. And then we kept solving, we got x is 3, right? So if we are solving, we're able to get that for our answer. And just as we don't need our common base, we just don't even need to worry about the common log. So if I have two log equations, or two logs, that have the same base. They both have a base of 5. I really don't care about the logarithm. All I care about is the insides. Because if it's log base 5 of 3, it also has to be log base 5 of 3 on the right-hand side. So I'm going to solve. I'm going to subtract x. I'm going to get 3x minus 7 equals 5. I'm going to add 7 on both sides. I'm going to move up here. 3x equals 12. I'm going to get x equals 4. Now, here is something that is a problem with a logarithm. On your calculator, here's what I need you to do. I need you to press the log button, and I need you to type in a 0. So log of 0. If you do that, it'll say an error. Because here's the problem. Log cannot have a 0 or negative numbers inside of it. So if this inside goes to 0 or a negative number, that is an extraneous solution. So with our log equations, we do need to worry about extraneous solutions. We have to worry about them. They might show up. So always substitute your answer. You want to make sure whatever inside the log is greater than or equal to 1. Oh, hold up. Actually, I lied. Sorry, guys. You just want to make sure that it's greater than 0. 0.5 also works inside of a log. It just can't be 0 or negatives. So let's plug 4 in. 4 times 4, that's 16 minus 7. Definitely not a negative nor 0. 4 plus 5, that's definitely 9. And they both are 9. Isn't that kind of cool? Kind of works out. Now, how do I solve an equation that has a log in it? Just one log, a single log. So I have log base 2 of x is equal to 6. How would I accomplish the task of solving this? Well, I can't get to the x, right? I can't divide by log. Kind of like how you can't divide by sign. It was sign of a number. I wonder if I can undo the log. Maybe I can go to a different form. Maybe I could convert to exponential form. So I could start at my base of 2, exponent of 6, and that would be equal to x. 2 to the 6th, I know that's 64. And then what you could do is plug that in, and if you did log of 64 divided by log of 2, aka change of base formula, you would get 6. Let's try using that in our example here. So I have log base 5 of x is equal to 3. Let's go ahead and convert to exponential because I'm stuck in log. I can't get to this x. So I'm going to start at the 5. 5 to the third is equal to x. Ooh, 5 to the third is 125. Now I'm going to double check. If I plug 125, that definitely is not 0 or a negative. So that definitely works in our equation. Let's try another one. I'm going to start with my base of x. Go to the 5, because remember, a log's answer is the exponent of a base. That's equal to 32. Log base 5 of 32, or x to the 5th, equals 32. Well, I would have to take the 5th root, right? If I actually am solving this, I would get x is 2, because 2 to the 5th is 32. And then my base of my log, I just can't have a negative there, nor 0. So 2 is okay. Now there's stuff inside of the log, not just an x. But notice, I still can't get to this x minus 4. I need to convert. So I'm going to go 2 to the third is equal to x minus 4. Now I need to figure out what 2 to the third is. 8 says my perfect roots chart. Solving, because x is not alone, got to add 4 on both sides. I'm going to get 12 is equal to x. Now, I got to double check. If I plug that back in here, is this 0 or is it negative? Well, 12 minus 4 is 8. That's definitely not 0, and it's definitely not negative. Check box, all good. And you could use your calculator if you wanted to make sure you got the right answer. So you could go log of 12 minus 4, aka 8, divided by log of 2, and you would get a 3. Ooh, a new thing has emerged. Notice we have the 7 plus log. When you are solving a logarithmic equation, which is what we're doing because they have logs in it, please make sure that the log is alone. So let's subtract 7. I need the log alone. So I'm going to get log with a base of 10 of x is equal to negative 3. Now, I got to convert to my exponential form because I can't get to the x. It's inside of a log. So I'm going to go 10 to the negative third is equal to x. Oh, 10 to the negative third. That is the same as, I'm going to go over here. Well, that is 1 over 10 cubed, right? Because negative exponents just mean go down to the bottom. And 10 cubed is 1,000. So x equals 1 over 1,000 for our answer. Now I'm going to go check, is that negative? Is that 0? If I plug it in, it is not. All good there. So go ahead and pause. See if you can get this answer for me. Oh, pretty easy, right? Because you probably just did like I did. And you went, Marsh, I can't think of an exponent that is 2 to that number is 5. That doesn't make sense. X is already solved for, isn't it? Let's figure out what log base 2 of 5 is. Again, you might need that change of base formula, depending on what kind of calculator you're using, which would be log of inside guy, big font guy, divided by log of 2. So log of 5 divided by log of 2. We shall get an answer of 2.3219. And I would recommend 4 decimal places for that answer. This one, notice, logs are equal to one another. Same base on the log. So what I can do is just set the insides equal. So I'm going to say 7x plus 3 is equal to 5x plus 9. Solving quick. Good old easy math here. I'm going to get 2x equals 6 I'm going to get x equals 3. Plug it in. Definitely not 0 or a negative. This one is definitely not 0 or a negative as well. We are good. And if we plug it in, we actually get 24 and 24. So both work in there. Let's try another one. Notice, same log, right? Log base 7 on both sides. So we actually can forget about them. But this guy, this log had a lot in it. I probably want to FOIL this so that I actually can see what it is. So I'm going to do a quick FOIL job on that. X squared plus 3x minus 2x minus 6. That's technically what was inside of this log on this side. I can just cancel the logs. Not technically cancel, but just drop them because I really don't care about them since they're the same. Combine my like terms. Oh, it is a squared. Solving in a quadratic, I probably want to get everybody the same side. So x squared plus x minus 20, just subtracted the 14 here, is equal to 0. I got a quadratic. I could solve it in many ways. I could complete the square. I could quadratic formula. However, you probably already have noticed it factors. So let's do a quick factoring job on that. The two things that multiply to give us x squared would be x and x. Two things that multiply to give us 20 would be 2 and 10, 5 and 4. 5 and 4, though, can make me a 1. So I'm going to use 5 and 4. I need a positive 5, a negative 4 to get me that added positive 1 when I multiply my outsides and my insides. So my answers, I get x equals negative 5 and x equals 4, setting both of those equal to 0. Now, again, please double check to make sure neither of these make it go to 0. So I'm going to plug in negative 5 in here. I'm going to get negative 7 times a negative 2. That is a positive 14. So negative 5, all good. Let's try a 4. 4 minus 2 would be 2. 4 plus 3 is 7. That is 14. All good there. Both answers are solutions to our equation. Let's try, actually, you know what? Let's have you guys try this one. So you should pause the video here. And you should see, can you get the answer? Don't forget to check your work as well. Check your answer when you're done. Just pause. Make sure you pause. All right, I'm going to assume you paused because it probably was a weird, awkward silence for a little bit. I'm stuck in log, can't solve any further, so I'm going to set myself to exponential form. 2 to the 5th is 32. 32 minus 7 is 25. Divide by 5. I'm going to get x equals 5. Double checking. Yep, not 0, not negative. 5 has to be a good answer. And the final question of the night. Again, I'm stuck in log. There's nothing in the front of the log or the back. Let's just convert. So I'm going to get 3 cubed is equal to x squared minus 6x. 3 cubed is 27. I'm going to subtract 27 to the other side. I'm going to get x squared minus 6x minus 27 is equal to 0. Let's go ahead and factor that. I'm going to get x and x to get an x squared. 9 and a 3 can make a 6. I need it to be a negative, so a negative 9, positive 3. So my two answers, x is 9 and x is negative 3. But wait, we got to check to make sure it checks. So I'm going to plug 9 in. That's going to be 81 minus 54. That sounds good. 9 plus 18. That sounds good too. Now, I know you are thinking, Marsh, We've checked 10 problems. Not a single one of these answers were extraneous. Don't worry, it can happen. So that's why you got to always be on guard. Got to make sure, what if one of them doesn't work? We'll always have to check our answers in a logarithmic equation because we have to worry about extraneous solutions. But with that, that is the end of this video. See you later, Sabers.